Welcome, everybody, to Practically Intelligent. I'm your host, Sinan, and Akshay is away this week. So we are going to try something a little bit different. I am going to be hosting the Practically Intelligent's first ever office hours. So if you have never if you've never had a chance to go to office hours in college with your TA, basically doors are open. If you have questions, come in and ask me questions about AI, about machine learning, data science, really anything. And I want to answer it. There is a form on our website, practicallyintelligent.com, where you can submit a question and we'll answer it on the show. I'll put a link to it, of course, in the description, and I'll say it again at the end of the episode. But if you don't know much about me outside of this show, I run a bunch of lectures for O'Reilly on LLMs, generative AI, transformer, RLHF, all kinds of stuff. And I give at least one lecture a week these days for the O'Reilly platform. And through those, I got a lot of questions. Just this morning, before I was recording this, I was recording a lecture in which I had at least 50 questions come my way. So I thought to kick us off, I would take a few common questions from my most recent lectures to use as a jumping off point. And then starting the next time that we do office hours, we'll take questions from you all, from our audience. All right. Question one, and I'm going to say these as verbatim as I can as I get them in my live lessons. Is prompt engineering dead? No. To put it simply, the longer answer to that is prompt engineering is kind of this wishy-washy term that has been used to cover a lot of use cases over the last couple of years. Simply put, prompt engineering is just crafting and designing an input to usually a generative AI, a generative LLM, like ChatGPT, Claude, what have you, to not only make the responses better, i.e. more accurate, reduce hallucinations, but also to make the responses a little bit more consistent. Consistent meaning that you can expect the structure of the response coming out of the model. And more importantly, for a lot of people, you can actually translate that prompt to multiple models. So if you're familiar with things like few shot learning, chain of thought prompting, those are the two main types of prompt engineering techniques out there, and they're pretty easy to master. It's just including different examples in your prompt or enticing the AI to actually explain its reasoning before answering a question. These are techniques that will actually translate between different LLMs. So if you write a good prompt for OpenAI, you should be able to translate it to Anthropic, to Cohere, to Llama, to Mistral, what have you. So prompt engineering, by no means, is dead. And in fact, one of the case studies in my most recent book, A Quick Start Guide to LLMs, I do a pretty rigorous case study on prompt engineering because people always tell you it's better, but they don't really show you that it's better. So the basic premise was, if I take a bunch of math word problems, not the GSM benchmark, but a different one, Math QA, and I ask Anthropic's Opus, Llama 3, GPT-4, 3.5, and all of these different models, if I ask the math word problems with various ranges of prompting, ranging from zero-shot prompting, no chain of thought, no few-shot example, just ask the question and get an answer, all the way to chain of thought learning with 3 or 5 shot prompting, and even taking it one step further using semantic K-shot, which is actually using the most relevant, semantically speaking, the most relevant examples from a data set rather than just randomly taking examples. You can actually see a performance increased, for Llama, for example, the performance went from 10% accuracy to 40% accuracy just by changing the prompt. For Opus, it went from 50% to about 70% accuracy. And again, the questions didn't change. The only things I was changing was, how many examples was it? Do I use few-shot learning? Simple things like that can actually really increase the performance of your prompt. So prompt engineering is not dead. What might be dead is the way of people kind of calling themselves prompt engineers, saying, hey, I know how to use the OpenAI API. I'll call myself a prompt engineer. And that's still a useful skill to know how to do that and how to do that effectively. But I think as AI kind of got easier and easier to use, simply knowing how to call the API or know how to do these prompting techniques was not enough. People had to start setting up testing harnesses, testing sets, iterating on prompts, trying different prompt model combinations as models came out, tweaking prompts to try to catch more edge cases as edge cases were found. So prompt engineering, the job of a prompt engineer has gotten larger. It's not just knowing prompting techniques and implementing them, but it's also about basic kind of machine learning ideas like what are edge cases, how do you catch them, and how do you account for them. All right, question 2. This is the one I get more often recently, which is, what is an AI agent and what makes them useful? Well, simply put, an AI agent is really nothing more than a well-engineered prompt attached to some external tool. So ChatGPT is itself an agent. The underlying LLM is GPT, let's say GPT-4 or GPT 3.5. But when you ask ChatGPT to draw me an image, for example, GPT-4 doesn't know how to do that. On its internal prompt behind the scenes, it has access to different tools. One of those tools is DALL-E, a separate image generation system. So when GPT-4 listens to me and says, and I say, make me an image, underneath the hood, it is deciding, before speaking, it is deciding I should call DALL-E to actually make this image. And then that kicks off a process. The image comes back and it shows it to me, and then it ingests it into the conversation. So my point is, agents are just generative LLMs with access to tools. And when you talk to an agent, you're really relying on its ability to figure out which tool it needs and in which order, and if it needs to call multiple tools to answer your question, and frankly, hoping it gets it right. And if you're building an agent, you can test that chain by saying, okay, when I ask this question, I expect you to pick these tools in order. And if you don't, I'm going to change my prompt and fix it. So that's what agents are today. Now, as LLMs get better at reasoning and better at processing input, you might see a reduction in the amount of kind of logical reasoning through, okay, the AI is going to say, well, first I need to call DALL-E, and then I need to do this. A lot of that might happen kind of at processing time. As you are processing the input, as the AI rather is processing the input, there might be some changes in the architecture that will mitigate the amount of output tokens there. But at the end of the day, an agent is simply just an LLM with access to external tools like Google something for me, draw me an image, even memories. What we in ChatGPT, when it remembers something about you, that tool is called Bio, I believe, under the hood. If you do some prompt injection, you can kind of see that they call it Bio. It is how it remembers stuff about you. I believe that's what it was called. So, and then Python, executing Python code is the fourth tool that ChatGPT has. So that's what an agent is. It's a well-engineered prompt against a well-performing model with access to well-defined tools. And my favorite question that I get pretty much in every lecture, some form of this question. What is the best model today? I usually have to take that with a whoo boy. Because the answer is depends on what are you trying to do, what data sets are you working with, and what are your constraints. A lot of people simply want to use generative AI models like ChatGPT to do things like classification, like input some text, output some labels. Easy peasy. But that's a lot of overkill in a lot of sense for trying to do some basic classification, especially if you already have some training data to train a BERT model, for example. I do a case study in my book where I take the same, it's a large data set. It's like tens of thousands of examples. I take a large data set and I fine tune both ChatGPT and a BERT model. So 175 billion parameters versus 70 million parameters in a distilled BERT model. And they both perform basically the same. So which one's better? Is it the open source model that I fine tuned, or is it the behemoth GPT 3.5 that also was fine tuned with the same data? Well, pricing would also be a factor. A BERT model can batch in classification inputs. You can do 32 at a time, 64 at a time. GPT, the way you construct the prompt, most likely can do one at a time. So throughput and latency are an issue. Cost is an issue. If I have to host BERT myself, that is some cost. But if I'm paying for an API call every time I want to do classification, that's also kind of an issue, isn't it? So best is not the right question. Which model is best is never the right question to ask. What model is going to work best for your task given this data set and your constraints? It's a longer question, but it's the right question that you need to ask yourself. Are you doing a generative task versus a classification or even a clustering or an embedding task? Are you limited by cost and compute resources? Do you have sensitive data that you can't even use OpenAI for in the first place? All of those things get factored into that question. And even if you want to say, fine, strip all that away and say, given the same data, given the same whatever, given the same everything, is GPT-4 better or worse than, let's say, Anthropic's 3.5 Sonnet? That's still not a fair question, because the only way that you would begin to answer that is through benchmarks, which are just test data sets. So you're still just going to test them against a testing data set. It's just that we call those testing data sets that we all kind of quote unquote agree on benchmarks. And even benchmarks have their own problems. Not every benchmark is going to be actually useful to the layperson. I talked about math Q&A earlier in this show. Not everybody cares about math word problems. That's fine. You don't need to pick the best model for math word problems if that's not your task. It's always going to come down to, can you effectively test your model against your data in a way that you can feel confident about? If you can't do that, there's not really an answer to the question, which model is best? Because frankly, you're just kind of going off of vibes. And hey, look, I'm here for the vibes. I'm here for, whatever it takes to kind of get you excited about using the AI. But at the end of the day, you want to have some level of confidence to be able to point to and say, this is better because this number is better, higher, or lower, depending on what it is, than this number. End of sentence. Okay, those are the 3 questions that I had for today. It's a pretty short episode, but we're just kind of testing out this format. If you do like it, go ahead and head over to practicallyintelligent.com, send us your question, and I'll answer it right on this show for you. Until then, we will await the glorious return of Akshay, and we can get back to our regularly scheduled programs. But I did hope you enjoyed our office hours with me, Sinan Ozdemir. I'll see you next time on Practically Intelligent.